We all know that computers can do a whole lot more than just processing numbers. So how is this possible if all data is just binary numbers, ones and zeros? The answer lies in the way software can use numbers to represent other types of information. This is called encoding. A common example is seen with text. Systems which rely on text, such as email, websites or documentation, use an encoding scheme to represent characters using numbers. There are international standards for doing this, so data can be shared between systems and around the world. The best known one, certainly in the Western world, is ASCII, for American Standard Code for Information Interchange. People often talk about ASCII data and they simply mean text. ANSI, for American National Standards Institute, extended the original 128 to 256 characters, and these days many applications use Unicode, which extends the character set further to include international character symbols. Unicode in fact defines thousands of characters, so many that a translation format is used to point to a specific character. The most common is UTF-8. The first 128 characters are the same as the original ASCII set. ANSI chose 256 characters because these can neatly be represented using just 8 bits, ones or zeros, or 1 byte of data. Or in hexadecimal, 1 byte is represented by 2 digits. Our normal decimal numbering system uses 10 digits, 0 to 9. In hexadecimal, or hex, there are 16 digits, 0 to 9 plus A to F. This is useful because a single hex digit represents the same number range as 4 binary digits. Hence, 2 hex digits can represent 8 binary digits or 1 byte. This makes hex a commonly used shorthand for representing binary numbers. Data representing a string of characters, in other words text, is often referred to as string data. In software coding, string data is often denoted using quotation marks. For example, we could assign a variable called myText with a string containing "life is good." The interpreter knows that this is text because of the quote characters. When the data is stored, it is stored as ASCII translated numbers, or perhaps Unicode, depending on the use case and the languages being used. To get full listings of ASCII, ANSI and Unicode translations, simply do an online search. Computers can of course be used to process numbers. Although we know all data is made of numbers, we still need to do some encoding, because there are different ways to represent numbers. In decimal, we have positive numbers, negative numbers and fractional numbers, using a decimal point. We can also represent very large or small numbers using scientific notation. In computers, we also have options for how we use binary ones and zeros to represent numbers. When writing code, we often have to declare which formats we are using, so programs can make sense of them. Some examples are integer, all whole numbers, positive and negative, and floating point. Similar in concept to scientific notation, it allows long numbers, including with fractional components, to be stored efficiently. I have shown how encoding can be used to store numbers and text. If you think about it, this covers quite a wide range of applications. Word processing, spreadsheets, stock control systems, accounting, and many other applications are all made possible. However, what about sights and sounds? How can computers work with images, video, and audio information? For these, we need to explore another form of digitization, and the topic of the next video in this course: analog to digital conversion.